Alright, so this is 432 hertz in a blackened liquid, just a blackened water, 432 hertz, going through the amplifier, lit from lights, vibrating this dish. Notice it doesn't look like anything. That's right, because 432 hertz is very high pitch, very high frequency, and is not doing well with this particular fluid. But I want to show that it does not produce any nice image. Now, I'm going to take this frequency and I'm going to now turn it to 440 hertz. And let's see what happens. Interestingly, this seems to have a better structure. It seems to be more stable, and it seems to be more structured in the center than the other one. But how could that be? I thought 432 hertz was the magic frequency. I thought 440 wasn't magic. It really doesn't matter. The frequency only has to do with the particular fluid and the particular vessel that I'm using. We're now going to change the vessel and try a different size vessel to see what happens. But notice the structure. Notice how nice it looks. Now let's go back to that 432 just to show the difference. And finally it's coming to. And now let's notice that this difference, it's more wobbly, it's not as coherent, and there it just lost itself. So it's got a little bit of a dot in it, there it goes entirely. So that proves that this 432, 440 nonsense is nonsense. There's nothing magical about 432. I'm going to go back to 440 just to show that it does indeed produce a better result in this particular fluid and this particular experiment. And again, I have to just let it go, and sure enough, there. Oh, look at that. 440 is much better than 432. See, this is 440 now. Vibrating this dish 440 times per second. This definitively proves that 432 is not the master plan. Again, dropping back down to 432, watch as it dissipates over time. That nice structure that we had from 440, look at that. It goes away. What? How could that be? That's not supposed to happen. Let's try another vessel. Earlier, we're going to start with 432 hertz. The point here is that when you change the fluid or you change the vessel size, you're going to change the physical system. So 432 hertz versus 440 hertz, that only matters in the particular fluid and the particular vessel. The moment you change that, everything changes. So the mean goal showing that 432 hertz is better than 440 is simply misleading. So let's check out what 442 hertz looks like. We're going to play this. You can hear it. We can see that it's vibrating the fluid. So let's see what that looks like from above with these lights reflecting down upon it. And as expected with most high frequency cymatics, it's not going to do well because liquid cymatics does well with low frequencies. But notice that it's a chaotic kind of form. There's not really any geometry forming. Let's see what happens when we go to 440. Now, just like with the larger vessel, it takes a moment to shift over, and let's see what the encounter is. So it already has some more structure than the 432, and it's trying to do something. Look at that. It bounced into a stable state. Now, technically this is not a geometric form, but it is a stable form. Compared to the chaos that we saw before, this is much more stable. Look at that fine ring around the center. Look at the fine dot in the middle. This is a frequency that resonates well. But wait a minute, how could that be true? Because it's 440. Again, look, we're on 440 hertz. Let's change it back to 440 or 432 just to show you that that matters. Automatically, that's gone. We see that a center's trying to form. We see that the fluid kind of tries to be stable, but there's too much rippling in between those attempted stable layers. Now see, that center is trying to form, but notice that it wiggles, it wobbles from side to side. It can't be stationary, it can't be structured well, because 440 or 432 hertz does not work well with this particular fluid and this particular vessel, just like it didn't work well with that one. So now I've got two vessels with the same fluid where 432 does not appear as good as 440. Let's change it back to 440 again. Let's just see the difference here. And it takes a moment for it to shift over. We see that shift, the center's nice and formed, and the fluid starts to respond right back to that stable center form. This one's a little bit more chaotic, but again, it's much more stable and much more structured than the other one. So it seems that adding in a different fluid or changing your vessel definitely changes the system. And you can make 440 appear much better than 432 very easily, folks. Do not be misled by the meme. 432 is not any better than 440. Again, shift it back to 432. Let's see what happens. So that's 440. We're going to shift it to 432. We hear the difference. Let's position the phone, the camera, and we see that that center dies away real rapidly. And in its place, we get these shifting bands that are trying to compete with each other. They're not able to form a stable relationship with this fluid, no matter what I've done. It tries, but as you can see, it wobbles. Now going back once more, finally, to 440. We've got 432. Listen for the change. Got the change. Let's see what happens. Same thing, as expected. Oh, that was interesting. Lost it. What's going on here? Oh, my fluid splattered. So that's one of the things, is that when you lose fluid, it changes the results. So let's add fluid. And there we go. Back to that kind of stable center with that ring around it. Now, since I changed the fluid, let's go ahead and go back to 432. Let's see what happens with that one since I changed the fluid. Take a second for that to shift. The middle ring starts to combat with itself. Let's see if it collapses. Sure enough, it collapsed. The center's a bit more pronounced in this one, but still nothing compared to the 440. Again, 432. Finally, one last time, shift it to 440. As expected. So folks, that's the real key here. There's no magic formula. There's no magic. 440 does just as well as 432. You just gotta choose the right fluid, the right vessel, and you can make any frequency appear however you want. That's it.